Section 6.6, Trapezoids and Kites. We're going to verify and use properties of trapezoids and kites. Starting with the trapezoid today. A trapezoid is a quadrilateral with exactly one pair of parallel sides. You can definitely tell on this one which sides are parallel. It's the bases, which are the top and the bottom. Normally when you kind of picture trapezoid in your head, picture it like this, not the ones that are kind of turned on their side or anything like that. So normally when you look at a trapezoid, the parallel ones are the bases, which are the top and the bottom. They are marked usually with a filled in triangle. If it isn't and it says it's a trapezoid, then you can assume that those are filled in triangles and go from there. Here, the legs definitely are not the same length and they are not parallel either. Otherwise, it would be a rectangle, okay, or a square or something like that. So the bases are the parallel sides. Look at the base angles. Make sure you know that there's two sets of them. Here's the base angles that go along with the bottom base. Here are the base angles that go along with the top base. Right now, these are not the same. Okay, if you talk about an isosceles trapezoid, which we'll talk about in a minute, then you might be talking about some angles that are the same. But right now, there's 4 base angles. They're just not the same here. The legs are the non-parallel sides. So when you look at the legs, those are going to be the ones between the bases. Here, again, they are not the same length. They define base angles, and I kind of talked about this, I just didn't use the same words. The two angles that share the base of a trapezoid. So again, the base at the bottom has 2 base angles that goes with it. The base at the top has 2 angles that go with it, which is basically the same as what they said. An isosceles trapezoid is a trapezoid with the legs that are the same. So when you look at this one, here they are marked the same. If it says in the directions that it's an isosceles trapezoid, you can mark the top and bottom parallel. You can mark the 2 legs the same. Okay. If a quad is an isosceles trapezoid, then each pair of base angles is congruent. So they have them marked. So angle T and angle P are going to be the same. Angle R and angle A are going to be the same. But notice how one of the sets is an acute pair, the other set is usually an obtuse pair. So you can kind of tell that these are definitely not the same, R and T. And so you have to go, the ones along the base are going to be the same. And that's if it's isosceles. If it isn't, they are not the same. So this one tells us that it is an isosceles trapezoid. The measure of angle C is 65. What are the measures of D, E, and F? So which one matches 65? Angle F is correct. So we already know that one. So this one is 65. How do we find out what the other ones are? Yep. And what kind of angles are they? Like if you look at D and C, what kind of angles are those? If these are parallel at the top and the bottom, and that's a transversal, wouldn't they be same side interior? And we already know that same side interior are 180. So we're going to take 180 and subtract 65, and that should give us both D and E, because D and E are the same. So what is that, 115? Okay, so measure of angle D and the measure of angle E equal 115. And the measure of angle F equals 65. Okay, so don't forget things that we already know. It's just that they don't draw in the parallel lines and the transversal, but definitely extend them if it makes you think a little bit. Also, when you think of a small angle and a big angle put together, usually I think what comes to mind is probably 180 degrees there too. So those that are on the left and the right of the base are the same. Okay, so in the diagram, we know that it's isosceles trapezoid. This is not definitely how I picture a trapezoid. I flip it so that the long side's on the bottom. That's just how I look at it in my head. Which angle is the same as 106? S. So when you look at them, again, these two are the acute angles, those two are the obtuse angles. So make those obtuse angles the same. So S is going to be 106. And then we know that how much are these two together? 180. So Q and P are both going to be the same. And what are they? 74. Okay, so the two base angles for QP are angle Q and angle P. The two base angles for RS would be R and S, and that's kind of how you look at them and make them the same. Okay, so here's kind of an application question. The second ring of the paper fan is shown. It consists of 20 congruent isosceles trapezoids that appear to form circles. What are the measures of the base angles of these trapezoids? So here, I'm going to make this one here a little bit bigger, but I wanted you to see the fan. So they're looking at the light pink part of it. That's where it forms those trapezoids. They want us to figure out what these missing angles are. Okay, so I'm going to make it a little bit bigger so that you can see it. So let's first of all look at where they have angle 1. How do we use that to get something? Because they really didn't give us any angles to go with. So what I'm looking at is these are all the same, right? Going around. What do they form? A circle. We know that circles are 360. So how many of these go around? And they're all going to be the same because it is isosceles trapezoid. So how many are there? 20. So first thing we're going to do is we're going to take 360 and divide it by 20, which is 18, to get this one right here. So angle 1 is 18. Okay, then we know that it's an isosceles triangle, right? So if we look at just the triangle itself and not the isosceles trapezoid part, I'm only looking at that, we have a triangle that looks like this. This angle right here would be the same as that one, and we already know that this is 18. So we have to figure out how many degrees are left for those bottom two. So I'm going to go 2x plus 18 equals 180 because there's 180 degrees in a triangle. 2x equals 162, and x would be 81. So this angle right here is 81, and this angle right here is 81. Now we can go back and do the trapezoid part. Just this part. How much would y be if we know that the one that is consecutive to it is 81? How much would this one be right here? How much do the two add up to? These two? Jazzy? 180. So 180 minus 81 would be what, 99? So angle y would be 99 and angle x would be 81. So sometimes they're going to give it to you in an application type thing where you might have to use other knowledge as well. So x is 81 and then y is 99. Okay, so here's got it number 2. A fan like the one in problem 2 has 15 angles meeting at the center. So basically you're going to be looking at exactly the same thing, only it's 15 angles instead. So you're going to take 360 and divide by 15 first. To get your main angle at the top. That gives you 24. So when we look at this triangle, this right here is 24. we need to find out how much those two are. So 180 minus 24 and then divide it by 2. Uh, 78. So that would be x. And then we take and subtract from 180 once again because they are same side interior angles. So 180 minus 78 would be 102. And that would be y. So same process, different interior, or different first angle, I guess, we're looking at. Then we come with the next two theorems. The first one says if a quadrilateral is an isosceles trapezoid, then its diagonals are the same. This one kind of should remind you of a rectangle a little bit because there the diagonals are the same as well. So if it's isosceles, or to prove eventually it's isosceles, we're going to show the diagonals are the same. Then we go to the mid-segment theorem, which we talked about a little bit already. You're going to take that top shorter segment plus the bottom longest segment and divide it by 2. So the mid-segment is kind of like the average that's in the middle. Okay, and that's how I remember that formula. It's pretty easy. So here it does say it's a mid-segment. We don't always have just numbers though. So what we're going to do is we're going to set up the formula first. So it's going to be QR is equal to the top plus the bottom and then divided by 2. So the middle is x plus 2. The top is 4x minus 10. The bottom is 8. And then we're going to divide it by 2. A little bit harder than just taking numbers. So I'm going to simplify that top part first. So it is 4x minus 2, and then we're going to divide it by 2. You can do this a couple different ways. Could you divide both of those things by 2, 4x and 2? Yep. Sometimes the numbers they give you don't always work. So another thing that you can do, so it could be like this, x plus 2 equals 2x minus 1, and then solve that. Or you can say, I don't want to divide those by 2 because they don't divide by 2. Sometimes they don't. And you can multiply both sides by 2. If you do that, though, it does look like this. Okay, so when you multiply the right side by 2, those 2's cancel out. When you multiply the left side by 2, you have to do the distributive property. Either way, you're going to get exactly the same answer. Most, I think, will just divide by 2, but again, you have to do both parts, not just one of them. Okay, so this one looks like 2x plus 4 equals 4x minus 2. I'm going to get the x's on the same side, the numbers on the other, and I get x equals 3. The other one, if we solve, I'm going to put an or in here, get the x's on the same side, the numbers on the other, and you get x equals 3. Sometimes these could be fractional numbers. A lot of times they are not. So just because you get a fraction doesn't mean it's wrong. You just have to check it. So if you actually put 3 in there, does it work? If you put 3 in here, you get 5, 8. If you put 3 in there, you get 12 minus 10 is 2. So does 5 equal 8 plus 2 divided by 2? Yes. So you can throw it back in there really, really easily and check to see if it works, especially if you get a decimal or a fraction there. The only way that it might not work if you get a decimal is if it isn't like 0.5, 0.75. If you get like a 2/3 or something goofy like that, leave it as a 2/3 just because then it might just work. But a lot of times these are just numbers. Every once in a while they'll throw one in that isn't. So super easy question, but make sure you're doing the right steps. So let's look at one more of those. Segment MN is the mid segment. So we're going to take that middle section and put it on the left. And we're going to take the top section plus the bottom section and divide it by 2. Which way do you think you guys will do this one? Will you divide everything by 2 the way it is? Or get rid of the 2 and multiply it? It doesn't really matter, but I'll do whatever you guys want. What do you think? Keep it or multiply it? Multiply it? Okay, let's do that. So if we multiply by 2, those are gone, and we get 2 parentheses 2x plus 11. And simplifying on the left, we get negative 2 plus 8x. And all I did was put the 10 and the negative 12 together. So 4x plus 22 equals negative 2 plus 8x. We'll put the x's on the same side, numbers on the other, and we get x equals 6. If we plug that in, we get 48 minus 12, that would be 36. And 12 plus 11, that would be 23. Is 46 divided by 2, 23? It is. So 10 plus 36 would be 46. If you divide it by 2, you should get that segment length that's in the middle. So super easy to check. You don't even really have to write it down. You can just do it on your calculator and see if that is right. Now, they also say, what is MN? We did that already. 2 times 6 plus 11 would be 23. Now, last part, kite. A quad with 2 pairs of consecutive sides congruent and no opposite sides congruent. So you can kind of think of this as 2 separate isosceles triangles. So the 2 that are on that top little shorter section are the same. And the 2 that are on the longer edges are also the same. Generally for a kite, that's what you picture kind of in your head. So that's one of the properties. Here's another one. The diagonals are perpendicular. When I look at this picture right here, think about actually flying a kite. And those, if you get one, sometimes they might be plastic, the T part in it. Sometimes they might be just a little kind of flimsier, like dowel, the little wood things. Those are perpendicular, and that's kind of what keeps it so that it stays open. The newer, fancier ones that are in like butterflies or, you know, those kinds of things, they're not totally flat like that. They are kind of curved a little bit, but they still are perpendicular to make them go. So that's going to be how you're going to actually get started on this one, is that perpendicular part needs to be written in there first. And I think that will get you going. So if those diagonals are perpendicular, they want to know what angles 1, 2, and 3 are. So I'm only looking at this triangle right here. So this right here is 52. The right angle is angle 1. So angle 1, oops, hold on, is 90. There's only one angle left to find. So when you're looking at it, you have 90 plus 52 plus angle 2. So it's all about finding that right angle first, subtracting them all from 180 to see what you get. And on this one, it is going to be 38. How about 3? What do you think 3 is? 52. It splits it into 2 triangles like this, top and bottom, that are the same. It also splits it into 2 triangles right, left, that are the same. So angle 3 is going to also be 52. So you don't necessarily have to go and find every angle, but they are going to have some similar triangles in there that are the same. And then we have one more. So we want the missing angle. So angle 1 is a right angle. What is angle N? How do we find that? They're not asking for it, but I want to know what it is. What do we subtract from? Okay. And how do we find that?
90 plus 36 and 180 minus that.
Yep. So 180 minus 90 minus 36 would give you angle N. And you said that was the same as angle 2, which is correct. So for this one, angle 2 is 54. And then how much is angle 3? 36. So really on these, there's only one that you actually have to calculate. Then you just have to know how to pair them up so that they look the same. They do give a concept summary here of all the shapes that we've learned so far, which is what you guys had to do your project on. We have parallelograms, rectangles, rhombus, squares. Those are kind of in a category. Quadrilaterals, we've got trapezoids and isosceles trapezoids. And then we have kites. It talks about how many sets of parallel sides that are there and also has everything marked. So if you're not sure, what you're looking at, this kind of gives everything in perspective. For a kite, the top 2 sides are the same, the bottom 2 are the same, no parallels. For trapezoids, you might have a set of you do have a set of parallels, but you might have some sides that are the same. Obviously, the top of a trapezoid and the bottom will never be the same. For parallelogram, you have 2 sets of parallels. For a rectangle, you have 4 right angles. For a rhombus, you have 4 congruent sides. And for a square, you have both of those. We have 4 right angles and 4 congruent sides. So it kind of puts everything all kind of in perspective in one picture.